This section 5.5 is solving rational inequalities. So the key word here, keywords, rational, and it's inequalities. So that means that it's a rational. So this is the case where last time I said, don't change my polynomial function, right? Polynomial function on the top there, into a rational function. Rational means that there's be x's or variables in the denominator. Right, so I said never, ever, ever divide by a variable because then you're changing a polynomial into a rational. Here, I'm starting you with a rational, right? So it's a rational function to begin with. You didn't create this, so this is already a rational function. And it's an inequality, not an equation. So an equation is when you'll get numbers. So you'll get x equals 2, x equals 2/3, x equals -9, x equals a certain value. An inequality is a range of numbers. So we're going to be looking for a range of numbers between 2 to 5, between -3 to -1, stuff like that. So between numbers. So inequality, you're going to get a range of numbers. It's different than solving because it's an inequality. So instead of just solving, what we were doing in the solving equations was solving for the roots. We were only looking for the roots. So now what we're doing is we are looking for, so I'll give you a little example here. So say, for instance, we had something like this, and we had, right, and something we've graphed. And we might go through and churn, something like that. We are looking, what we were doing before, so it could be super complicated, we were looking for roots. That's what we were solving for before, right? We're just looking for the roots. Now what we're doing is we're looking for a range of when it's below 0 or above 0. So there could be things happening that are irrelevant to the root. The root could be here and we don't know what's happening here. Or it could potentially go through and maybe it's over here and there's another root and we're looking for that root and when it's above and below. So do you see how the asymptote makes things more complicated, right? So before what we were doing in chapter 4 was the inequalities of a polynomial function. So the only thing that ever happened was that it could hit order 2 or 3, etc. It was going through. So these roots were it. We didn't need to know anything else. Now that there's asymptotes, asymptotes can have different things happening on either end of an asymptote. So just because there's an asymptote here, it could do this. So it could go from positive to positive, right? Not negative to positive, so we don't know. So the asymptote is not telling us whether or not it's positive to negative or negative to positive. So not like a polynomial. Polynomial was more straightforward. You looked at the order, you looked at what was happening. So now that there's asymptotes, a lot more things can be happening. Okay, so we have to solve an inequality different than the roots. The roots are just root. Just where does it hit the x-axis, so an inequality. What you could do is you could graph both the functions. So here, I could graph both of these functions, look at for intersection points. This is not a useful method. So trying to graph two rational functions and look for intersection points, this is awful, we will not use. Not good, okay? So not gonna use. So only useful, not useful, without technology. So that would only be useful if I had technology to help me. So if I had a computer and say, oh, the computer graphed it, then I got my lovely numbers, that would be fine. So we're not going to use that without technology, so it'd have to be done with a computer. So the other way we're going to do it is this way. So we are going to use this way. This is going to be our good way to use it. So yes, check. We are going to combine the functions, determining the zeros, and then check on a number line. So this is the method we're going to do. Combine the function means, so this part here means bring it to the left side. Left or right side, and other side equals 0. So that's what combining the functions mean. And then we'll determine the zeros. So you're going to bring everything to the left side. So your brain is saying left or right side and the other side equals 0. Okay, that's what combining functions means. It's bringing them over and then determine the zeros. And then the check on a number line. The number line check is something that I'm going to show you. And I know I mentioned this before when we did the polynomials. But the polynomials were so easy to graph, there is no point in doing it on a number line. Right? So here, the graphs are more complicated. So trying to do a graph of, and you saw, right, from the previous sections, trying to do graphs with asymptotes means you have to check the approach, left, right. It's a lot more work. A number line is much faster in this case. Graphing is going to take you too long. Okay, so always include the vertical asymptote in the solution in the number line. Really, 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 really important. Okay, so we're going to highlight this. Really, really, really important. I'm going to show you that on the number line what I mean. The vertical asymptote should be on the number line because look, it doesn't come up as a root. See, this is a root. That's a root, and that's a root. True? The asymptote also changes it, and it might change it from positive to negative. So you have to include your asymptotes, right? This is an asymptote. I was trying to show a quick asymptote on your number line to see if it changes from positive to negative or positive to positive. You don't know. You don't know what's happening there. Okay, so you have to check to see if the graph is above or below when it goes to an asymptote as well, not just the roots. Okay, so we want to include that in. Make sure you know how to do a lowest common denominator, just like in grade 11, so we're going to practice that. The x values cannot be included in the solution set, and I'll explain what that means here. That kind of relates back to this part, and I'll explain this line and that line, the two lines here, when we get to our answers. So I'll explain that in a minute. Okay, so here. First thing we're going to do is your brain is telling you left or right side and the other side equals 0. I don't care which side you bring it to, your answer will change depending on. So if I bring everything to the right side and say it's less than 0, you'll be looking below. If I bring it to the left side and say it's greater than the 0, you'll be looking above. The question will fix itself based on which side you're graphing it, because you've either taken the graph and flipped it this way or flipped it this way or that way based on which side. So some people ask me, what if I bring it to the right side? Will it work? Yes, because you'll be looking for above or below 0. I brought it to the left side. I'll be looking for above 0. But the graphs will be opposite. Our two graphs will be opposite. But I'm not graphing it, right? So I'm not graphing. I'm just going to do a number line, which I'll show you, right? So it doesn't matter which side. I'm going to bring it to this side. So I'm using this left or right side idea right here. And I'm going to go 240. I'm going to write it again. If you're not sure how long the question is, start it on the left side of the space I give you so that you can go to the right. I'm telling you right now it's going to be a longer question, so start it on the left side and we're going to go to the right and do the number line here. Okay, so start it here, 240 over t plus 8 minus, so bring it over, 20t over t plus 1 is greater than 0. Okay. We're going to do lowest common denominator, just like we learned in grade 11, so this still holds true. T plus 1, t plus 1. You don't have to show me this, but for your notes, I'm going t plus 8, t plus 8. Then the next line that you would show me, you'd go 240, t plus 1. You might do this a little faster. Minus 20t times t plus 8 all over t plus 1. T plus 8 greater than 0. Is that okay? Okay. So now, your instinct is going to tell you something, and you're going to resist your instinct and listen to me instead. Okay? Do not take this and bring it up here and make it 0. We did that. Yeah, you're going to be like, but wait, we've been doing that all along. Right. What did we do in 5-4? Solving an equation. Whoops, sorry. Solving an equation. When you're solving an equation, one more time, we are only looking for the dots. We're only looking for the roots. The asymptote was the restriction, so say don't equal that, and you're like, yeah, I'm just looking for the roots anyway. So solving an equation. Now I'm looking for the range of when it's above and below. If you take away the asymptote, you might be taking away a spot where the graph changed from positive to negative or negative to positive. You cannot ignore the asymptote. And you know, right, from doing our approaches, it could approach left and right and left. We don't know what's happening, right? So you cannot get rid of an asymptote. Why did we get rid of asymptotes for equations? Because it wasn't the answer. The roots were the answer. It only could equal. The asymptotes were the restriction. Don't make sure your answer isn't the restriction. We're good to go. Now, your restrictions are actually part of your answer. And when you do your answer, you want to say that it was positive until t equals -1, but not including -1, right? This is never part of your answer. That's what I was saying in the second part here. You can't include this in your solution set because it's not allowed to equal. So if you take this and dump it up, you've now created a polynomial equation out of my rational equation, inequality. Okay? I want it to be a rational inequality. Why does it not matter for the equation? Because it's never going to be an answer. We just stated it as a restriction. Said don't equal -1, don't equal -8, we're good to go, and we left. Now it's actually part of our number line. Okay? So for an inequality, do not eliminate, what can I say? Eliminate denominator. Okay? Ever, 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 ever. Okay, you're losing your asymptotes, you're losing a possibility when the graph could be going positive, negative. Plus, now on your solution set, remember when we did domain and stuff, and I said, okay, there's an asymptote here, dot, 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 dot. You would say my domain goes to say this is x equals 3. You would say my domain goes from negative infinity to 3, not including 3, and then jump here. That's what I'm saying here. It cannot be included in your answer. It has to jump over the asymptote. If you dump it over here, there's no way you're going to, like, where's the negative 1? You're going to go right through your asymptote. So it has to be included in your solution set. Okay? So never, ever dump for, do not eliminate denominator for inequalities. Inequalities. Okay? We did it for the last section because it wasn't an answer. But remember, first step, right? So here, do not eliminate denominators for inequalities. But look, my first step, I mentioned it. I didn't just eliminate it and not mention it. I said don't equal it here. First step, don't equal it. Right? Does that make sense? So it's not like we ignored it completely. I mentioned it, made sure it wasn't my answer, but now I have to make sure it's part of my whole number line, okay, when I do my answer. So it's very, very important. Stress that enough. Promise not to. Promise, 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 promise. Don't. Okay? Literally, you take it, dump it off here. You've dumped a bunch of your answer. You're going to lose a bunch of marks. Okay? You'll see wet stains here, my tears. I'll circle it and put an arrow and say, my tear. Tears of sadness. Don't dump. Make sense? Do not dump, one more time. I don't want to see that mistake at all. Right? Ever. For an inequality, do not eliminate the denominator because of this. It's an inequality. Don't drop it up. Don't bring it up. Just say, she said something about crying and tears. What was it? Okay? Do not. I know we did it the last section, but it's because it wasn't our answer. But we remember, look, we accommodated for here. We said don't equal it, but that's for a root. That's the dots. Now I need the whole range. Have I emphasized that enough? Yes. Maybe not enough. One more time, right? Okay? So I'll keep saying it again. Don't drop the denominator. Okay, now let's go and solve it. So we're going to do 1, 2, 1, 2. Go ahead and solve. So it'll be 240t plus 240 minus 20t squared minus 160t all over. Don't drop your denominator. Leave it factored. Beautiful, beautiful. And then finish this off, and I get negatives. We have to keep going. Negative 20t squared. Those add up to be 80t plus 240 all over. And then you keep going. So as much as possible, right? So what we kept saying to you in grade 11, if you can keep factoring at the end, keep going. I can common factor that out. So I'm going to take my common factor of negative 20. And then I'm leaving t squared minus 4t minus 12. And this is t plus 1, t plus 8. Okay, so do not dump the denominator. I need it here for my answer. Okay, and I never used to understand that. I was like, why can't I? And it's because inequality versus an equation. Equation, okay, because you stated restrictions here. Keep it, keep it, keep it. Okay, all the way through, we keep writing it. I know it's a pain. Keep writing it. It's important. I can do it one more time. So I'm going to drag this up. So when I need a new column, make sure you swoop up here. Put it at the top because I'm going to have to do something underneath. Okay, we don't need a ton of room, but I need room underneath. So one more time, I'm going to factor it. Negative 20. I get t minus 6. And t plus 2, all over t plus 1 and t plus 8. And that's greater than 0. Is that okay? Yes?
Can't you get rid of that 8 part?
No. Very good question, and I'm going to explain that right now. Exactly. Okay, so the question was, can you get rid of the negative 20? One more time. If you divide, yes, so yes with a caveat. Okay, so yes, but. If I divide both sides by a negative 20, what will you promise to remember to do if you divide by a negative? Yes, and that's what people forget to do. People go 0, 0, 0. I can get rid of so many things. You can do that for an equation. okay? So I'll show you why again. So if we go negative 20 and we get t plus, I'm just making up a number, so this equals 0, you go right ahead. Get rid of the negative 20. You're dividing both sides by negative 20. That's good. It stays t plus 3 equals 0. Yes, that makes sense. Okay, that's an equation. If you did this for an inequality, if you divide by a negative, you have to switch the sign. Why is that? Because, again, we learned this back in grade 9, an inequality, when you change from one side of the number line to the other side, negatives to positive, you've now changed the, you've now changed the number line. So negative 60 is now a positive 60, so now it's a big number instead of a small number. Right? So when you're changing the sign of something, and again, we learned this way back in grade 9, right? So when you divide or multiply by a negative number, it changes the direction here. So I sometimes recommend not to do it. If you're like, I'm not going to remember to do that or not, because it's been a while, then just don't get rid of any numbers. I keep it as one of the factors. So if you do it, switch the direction. If you choose not to, which sometimes I'm like, just don't do it if you can't remember when to do it or when not to, what I do is I go, this is one of the factors. If I have that factor in a quadratic, so if I gave you the quadratic, say x squared plus 3x plus 2, that we know opens up. What happens with the negative in front? It opens down. So this changes the direction. You can't just ignore it because it doesn't equal 0. And if you do have an inequality, you would flip the sign because look, that's what happened. That's why it's flipping directions, because it was above, but now we have the parabola upside down. So I explain it that way as well. Does that make sense? Right? So if you're changing the direction of your function, it's not a parabola, it isn't a parabola, but same idea, then you have to flip the direction because now instead of above or below, your function is the other way. Okay? So sometimes you're like, I'm not sure if I'm going to remember that, so keep it. So then leave it there, just don't cancel. So then don't cancel. But this is one of my factors now. So what I do on my number line, so I'll show you how to do the number line, and then I'll show you what a factor table is as well. Different teachers have different preferences. I don't mind either one you do as long as you can do it in a timely way, right? If it takes you twice as long to do a factor table, then make sure you do it faster, like learn how to do it faster, or change methods. So leave a bit of space here, because I'm going to put some work above here to explain some stuff. So put a little bit of space here. Make it a nice long number line so you don't have to write too small. Some of you guys write so small, you can't read your own writing, and I can't read it either. Okay, nice and big so we can do a bit. That's why I spaced it out so we can do some work here. We're going to put all of these roots, the top are roots and the bottoms are asymptotes, right? So the top here are the roots. So I'm going to go 6, -2, -1, and -8. I'm putting all of them. So then I'm going to go, and I space them out. So I just do 6, -1, I've got a -2, and a -8. I just make them evenly spaced. I don't care. We're not graphing it. Okay, I'm not graphing it. I don't think that that's the best way to do it, by doing the whole graph. You could, supposedly, it's going to take you forever. You're not going to finish. You're going to be like, I couldn't finish the test. I'm like, because you're graphing everything. So number line is much faster. So I put them equally spaced. Just make sure it goes left to right. Okay? Then you're going to check your factors. So this number line is like a factor table, but I check it on here. So then my factors are -20. So keep the -20, like that, and then just make sure that you know that there is a negative for all of these functions. There's a times negative on each one of these. If it was a +20, I wouldn't care, because a positive times anything doesn't matter. But I know that all of these factors are multiplied by a -20 on the outside. Then I'm going to look at each one of the factors. And if it's factorable, it's so wonderful. Okay, we still have students who say, no, I don't want a factor, I'm going to plug it into here. I'm like, yeah, you know what, why don't you just plug it into here? Why don't you just make it longer and add a couple factors? Why would you do it in the worst way possible? Like, that's awful to plug it. If I'm plugging a number into t-6, I can find it very quickly. I'm going to show you what I mean in a minute, right? So I want you to plug it into the factored form. This is the best method to use. Then you're going to tell me if it's a negative or positive. So these are the factors on the top. These are the roots, correct? These are the roots. So if I was solving an equation, I would dump the denominator and say, put it as a restriction and only look at the tops. Okay. Now, what I've got now, I've got the roots and I've got the asymptotes. When I plot the asymptotes for myself, this is more of a me thing. I tell other teachers, right, as well, so some of them go, oh, that's a good idea. So here, I put here, just for myself, vertical asymptote, just to note for myself. And here, vertical asymptote. Just all above my number line. That way when I'm answering it, I make sure that there's never going to be a square bracket on my vertical asymptote. Sometimes you guys forget, you're going too fast, you put square bracket, oh no, shoot square round, what did I do? Right? So if I do that and I just, every number line I go vertical asymptote, then I know. Right? And when would you use a square bracket? If that was what? Yeah, equal to. Okay? So equal to, you'd use square brackets, but never on an asymptote. That's what this line is saying. It says don't include the VA on, right, the vertical asymptote on the solution set. So open dot. So that's what this is saying. So open dot. Never included. Never included. It has to be open dot. So that's what this part here is saying. Does that make sense? So I put that down and I tell myself, because it's going to be open dot no matter, even if it was equal. And that's usually where people make a mistake. So our last example today, we'll do the ABC. C1, it's a square, and so you've got to make sure you don't grab it, right? So I do this as for myself, as a note to myself. It's more of a me note versus a method, right? So just for myself, okay? So I do myself. You don't have to. That's optional, right? So this is optional. I do it to remind myself it's open dot no matter what. Okay. Then we're going to test values. So what I mean by test values is this. I go like this. I say, okay, for the left of -8, what's a value to the left of -8? And in my brain, remember this is my brain thinking, you don't have to write it. Whenever it's in a bubble, that's my brain going x equal -9. I plug in -9 into my factors. And I go, okay, so then when I look at my first factor, I already saw that the first factor was negative. I have to include that because it changes, right? My parabola either opens up or down. So I do have to include the negative. I got that. I'm going to highlight that. So this is where I got this first number from. From here, that there, the -20. If it's positive 20, I don't care. Don't worry about it. Okay, but if it's negative, I do need it. Okay, put in -9 into this factor. -9 minus 6, -15. I don't care about the number. Is it a positive or a negative? It's a negative. So see how easy it is to do when it's factored form? Right? So you're just doing it in your head, and I don't have to touch my calculator. -9 plus 2, negative number. -7, negative. I don't care what the number is. So I'm showing you each one of my factors. Then I go to the bottom, and I go -9 plus 1, which is a -8, and I write it below. So this way, I've got all the information. So if you want to check with someone else and go, wait, how come I got positive? What did you get? You can still check. So I go -9 plus 8, -1, so negative. So see how fast it is when you have nice little linear factors?